Okay, today we want to look at a lesson on scientific notation. Scientists love numbers. We work with a lot of numbers, calculations, and work with numbers that are large and small, right? Numbers that describe all kinds of things. And so part of learning science is learning how to deal with numbers, how to manipulate numbers. So let's look at some possible numbers that we might want to be interested in. What is the distance between the Earth and the Moon? In case you don't know that one by heart, I'll put that one up here. 384,400,000. But I'm not done yet, right? Doesn't really mean much unless you know the units, right? Is it miles? No, it's not miles, it's meters. Scientists use M for meters. Scientists like meters. It's the international unit, the standard unit of length. What's the radius of a gold atom? This should be a small number, and it is. And this one has a bunch of zeros. I got the right number of zeros there. 1, 3, 5. And this is pretty small. So you see the problem here, right? There's a lot of zeros, and what are the zeros really doing? Maybe they're just kind of placeholders, right, and not really doing a whole lot for you. And there's a couple ways to get around this. One is to change the units. If meters, this one is also meters, if meters is not a convenient unit, maybe we can change it to something else that would be give us a better number, right? That's how we work with metric prefixes, for example. But we can also write the numbers in scientific notation. Scientific notation gives us the numbers without all the zeros, basically, and allows you to put it in a standard format. So let's see what we got with scientific notation. What is scientific notation? Well, scientific notation is consisting of a coefficient, which is just a number between 1 and 10. In fact, the coefficient is a number between 1 and 10, and you multiply that coefficient times a power of 10. And power of 10 is 10 to something, an integer, 10 to 1 or 3 or 4. And then we like to use units, right? You have to know what the units are, especially if you're using the number in a calculation. And the coefficient usually has a decimal point. For example, 3.844, number between 1 and 10, has a decimal point on it, which is fine, which is the typical case, times 10, and we'll give it power of 10 to 8th, right? We write that as an exponent, superscript, and we'll use meters as we did before. Some formats, you see, they don't like to write the exponent, and so they come up with ways of getting around that, like saying E, replacing times 10, and then like 0.8 meters, right? So some calculators do that kind of thing, and Excel also sometimes. But usually when we're writing things, we like to use 10 to the power of something, an integer, and that's usually the typical way that you see it written. Okay, so how do you change a standard number to a scientific notation? All right, so I said we can get rid of the zeros, and so we want to write this number. I do have other colors here. I'm going to write this number as some number between 1 and 10 times the power of 10. So we do that simply by putting a decimal point between the 3 and the 8. Right? Put a decimal point after the first number, and now we have a number between 1 and 10. And multiply that times the power of 10. And it's going to be in meters, right? So what number am I going to use for the power of 10? That's the question. So the way I do it is I say, well, the decimal point is here originally, right? If we were to put a decimal point in this number, we would put it way at the end. And we start from here and we go left. We go 1, 2, 3, 4, 5, 6, 7, 8 points to the left. So the exponent is 8 and it's positive. And the little way I remember this is I have a little saying that says, if it was left up to me, Okay, so left up, right? Left goes up. Right, so I remember that left is going up. And if it was left up to me, well, how am I going to finish this thing? Let's look at the other case where you have a number that's less than 1. And now I use the same approach. I say, well, I want to have the decimal point here, right, between the 1 and the 3. And that'll give me a number between 1 and 10 that I can use as my coefficient. I'm going to multiply that times the power of 10. I'm going to keep the units the same. Now I have a starting point here with where the decimal point is really at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. And the exponent is 10, but it's negative 10 because I'm going to the right. I'm making those, it's a smaller number, less than 1. Right? So if it was left up to me, chemistry would be down, right, easy. So if it was left up to me, chemistry would be down, right, easy. So left, up, down, right. So if I'm going to the right, the exponent goes down. If I'm going to the left, it's going to be up. So let's see how that all works out. See if we can do some other things here. How about if we start out with scientific notation and we want to end up with a standard number? So the diameter of the Earth is 1.28 times 10 to the 7th meters. So you wonder how they measure all this stuff, right? Distance between the Earth and the Moon, the radius of a gold atom, the diameter of the Earth. These people are not using yardsticks, I'll tell you that much. But that's an interesting question. You could do some research on how they get these measurements, how they come up with these things. So I want to change this into a standard number that doesn't have the power of 10 on it. So it's going to be 128. I want to shift the decimal point away from between the 1 and the 2. And I have to put some zeros on there. I'm going to have to put some zeros on there. And that's determined by where the decimal point is originally, which is between the 1 and the 2. And I want to take away the 7. So I take away the 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to take away the 7 by adding 5 zeros to the number. So now I took the decimal point from between the 1 and the 2. I put it at the end of the number, reducing the 7 to 0, and now because I'm going right, so the exponent is going down, right? So 7, 6, 5, 4, 3, 2, 1, 0, right? And then I can rewrite the number, put the commas in. It's a helpful way of writing numbers. Kind of helps us keep track of the units, the zeros. And of course, this is all in meters. Right? I'm going to forget our units here. Okay, well, how about if you have a negative exponent, a smaller number? I have 2.5. So I want to move the decimal place to the left. So I'm going to reduce, or I'm going to add to the exponent, right? Add to the exponent. So I start out here between the 2 and the 5, and I'm going to go left so I can add to the exponent. And I'm going to go 4 places to the left. And I put in my zeros. And typically we don't leave the number like that. We want to show that this is a number that is a decimal number that is less than 1. So we do put in the decimal point and the 0 in the units place. Otherwise, just 3 zeros before a 2 and a 5 is kind of confusing. Does that mean that that's a decimal number, or does it mean that there's just some random zeros there? But this way, it's clear, that it is a number less than 1. And of course, this is grams, right? This is the lowly fruit fly, giant fruit fly, I guess, for on this slide. But it doesn't weigh much, though. Should I do my fruit fly imitation for you? Buzz. There's an issue with scientific notation. What about numbers that are already between 1 and 10, right? 5.67 is already between 1 and 10. And you know, I could write this in the standard scientific notation format. I could say it's 5.67 times 10 to the 0, right? 10 to the 0 is 1. Right? 10 to the 0 is equal to 1. I could say that, but typically we leave this out. It's kind of redundant, you know, saying we're going to multiply the number times 1. Find that kind of redundant. So I mean, it in my mind, it's not wrong. If you write times 10 to the 0, that's fine. But usually we leave that out, and it's kind of an exception. You know, you always got to have always have those exceptions in science, and this is one of them where if the number is already between 1 and 10, we don't bother to put the times 10 to the 0 to make it officially scientific notation. Let's say you have a number with already has power of 10. It's not written in scientific notation, but it has a power of 10 and you want to convert it to scientific notation. We can do that too. This one here, we want to move the decimal point to the left because we want to have 0.235, right? Because that's number between 1 and 10. So we move in order to do that, we have to move the decimal place to the left 2 places. So what do we do with that 2? Well, we're going to add it on to the 6 because we move it left, so the exponent is going up. All right, so we have to add that number to the 6. And we're using liters as a unit. Liters is a unit of volume. Okay, so we'll see that later on, certainly, in chemistry. And so we've got to add the exponents here, which is not too tough. 6 plus 2 is 8, so you know, put the liters on there. Got it. The next one, 57.2 times 10 to the negative 4th. Here we want our number to be 5.72, number between 1 and 10. And in order to do that, we have to move the decimal place to the left 1 space. So left up. So we're going to add the exponent to minus 4. Minus 4 plus 1 is minus 3. And we'll put grams on there. All right, so moving the decimal place to the left, we increase the exponent by the number of spaces. And what about if you're using numbers that are want to go the other way? 7.73, right? That's what we want to use, times 10 to the 6th. And to do that, we have to move the decimal point over 1, 2, 3, 4 places to the right. So right, we go down. So we're going to subtract that exponent. And so we have 7.73 times 10 to the 2nd seconds. I'm using seconds here. Sure I got that there. And another case, we want to have 2.74 times 10 to the minus 4th. And in order to get there, we have to move the decimal place to the right 3 places. So minus 4, minus 3, right? Moving to the right. So the exponent is going to have to decrease. And it's 2.74 times 10 to the minus 7. And meters. Okay. So we learned how to write a number in scientific notation and how to do some conversions, right? How to move that decimal place around and write the correct exponent every time, right? So that's usually the issue, right? Is getting the right exponent once you've moved the decimal place around, getting the exponent correct. And you know, we've given some examples of going back and forth, and hopefully, you know, this is going to be helpful to you. And thank you.